Have you ever felt so cold your bones ache? We think of Antarctica as the ultimate deep freeze. But what if I told you the coldest place in the universe isn't on some distant, icy planet? It's actually right here, in a lab created by humans. Let's start with the cosmic baseline. The average temperature of the universe is about 2.7 Kelvin, just a couple of degrees above absolute zero. Absolute zero, or 0 Kelvin, is a theoretical point where all atomic motion stops. The coldest anything can possibly get, a staggering minus 273.15 degrees Celsius. The background radiation from the Big Bang keeps most of space just slightly warmer than that. So, is there anywhere naturally colder? Yes. Meet the Boomerang Nebula, 5,000 light-years away. It holds the record for the coldest known natural place in the cosmos at a frosty 1 degree Kelvin. That's colder than the universe's own background glow. How? The nebula is a dying star rapidly expanding and shedding gas. This expansion acts like a cosmic refrigerator, cooling the gas down. Think about how an aerosol can get cold when you spray it. The Boomerang Nebula is doing that on an astronomical scale. For a long time, we thought this was the undisputed champion of cold. But here's the twist. The coldest place in the entire universe isn't out in the cosmos. It's in laboratories right here on Earth. Scientists have been in a race to the bottom, pushing the limits of cold for decades. Using incredibly sophisticated techniques with lasers and magnetic fields, they've achieved temperatures almost unbelievably close to absolute zero. This isn't just about winning a cosmic coldness competition. Reaching these ultra-low temperatures allows us to see the weird and wonderful world of quantum mechanics in action. When matter gets this cold, it starts to behave in ways that defy our everyday intuition. Atoms slow down so much they can be studied with incredible precision. One of the most bizarre states of matter that appears is called a Bose-Einstein Condensate, or BEC. Imagine cooling a cloud of atoms to just a hair's breadth above absolute zero. The atoms lose their individual identities and start to act like a single, giant superatom, all moving in perfect unison. It's a state of matter where quantum effects, usually only visible at the subatomic level, suddenly become visible on a macroscopic scale. It's like getting a giant magnifying glass for the quantum world. The record for the coldest temperature ever was set in a German laboratory. Scientists there cooled a cloud of rubidium atoms down to just 38 picokelvins. A picokelvin is 1 trillionth of a Kelvin. That's 38 trillionths of a degree above absolute zero. It's a temperature so cold our minds can barely comprehend it. To put it in perspective, the difference between this temperature and absolute zero is far smaller than the difference between deep space and the Boomerang Nebula. Even crazier, scientists have taken this experiment into space. NASA's Cold Atom Lab on the International Space Station is a dedicated facility for studying these ultra-cold atoms. Why do it in space? Because on Earth, gravity is a constant nuisance. It pulls the atoms down, and researchers only have a fraction of a second to observe them before they fall. In the microgravity environment of the space station, they can observe these Bose-Einstein condensates for up to 10 seconds. This allows for more precise measurements and a deeper understanding of quantum phenomena. So, the next time you're shivering on a cold day, remember the true champions of cold. From the natural wonder of the Boomerang Nebula to the mind-boggling achievements in labs on Earth and in orbit, our quest to reach absolute zero is revealing a whole new side of the universe, one that is both fantastically strange and incredibly beautiful. Thanks for watching, and if you enjoyed this journey to the coldest corners of the cosmos, don't forget to like, subscribe, and hit that notification bell for more deep dives into the wonders of science. See you next time.